This is SpaceTime Series 28, Episode 36, for broadcast on the 24th of March 2025. Coming up on SpaceTime, space tornadoes discovered in the Milky Way's core, SpaceX's Starship to undertake a mission to Mars next year, and stranded astronauts finally return home after 9 months in space. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered enormous space tornadoes swirling through the Milky Way central core. The spectacular find, reported in the journal Astronomy and Astrophysics, was made while observing the turbulent region surrounding the Sagittarius A star supermassive black hole at the centre of our galaxy. The area is full of dust and gases, constantly churning as energetic shock waves ripple throughout. Astronomers using ALMA, the Atacama Large Millimeter submillimeter array radio telescope in Chile, discovered a surprising new filamentary structure in this mysterious region of space. Although the galaxy's central molecular zone has long been known to be a region filled with swirling dust and gas molecules cycling through formation and destruction, the mechanism that drives this process has remained elusive. Molecules serve as tracers for various processes in molecular clouds, with silicon monoxide being especially useful in detecting the presence of shock waves. So, using ALMA's high resolution and sensitivity to map distinct spectral lines within molecular clouds at the galactic centre, astronomers detected a new type of long, narrow filamentary structure at a significantly finer scale. The dynamic interaction between this turbulent environment and the slim filaments produced as shocks ripple through provide a more complete picture of cyclic processes in the central molecular zone region. The study's lead author, Kai Yang from the Shanghai Jiao Tong University, says the long narrow filaments are spatially offset from any star-forming regions. Yang says the slim filaments were an unexpected serendipitous find in the emission lines of silicon monoxide as well as 8 other molecules. Their line-of-sight velocities were inconsistent with outflows, and they don't fit the profile of other previously discovered types of dense gas filaments. They also show no association with dust emissions, and they don't appear to be in hydrostatic equilibrium. Instead, they appear as space tornadoes, violent streams of gas forming and dissipating quickly, distributing materials into the surrounding environment. Now, the authors still don't know how these slim filaments are formed, but they think shock processes are a likely explanation. Now, that's based on several key observations, including the rotational transition of silicon monoxide seen in the ALMA observations, as well as the presence of methanol masers and the relative abundances of complex organic molecules within these slim filaments. This breakthrough offers a new, more detailed view of the dynamic processes occurring in the central molecular zone of the galaxy, and it suggests a cyclic process of material circulation. So what's going on? Well, the best we can figure out, first, shocks act as a mechanism to create these slim filaments, in the process releasing silicon monoxide and several complex organic molecules such as methanol, acetone nitrate, and cyanoacetylene into the gas phase and into the interstellar medium. Then the slim filaments dissipate and refuel the widespread shock-released material in the central molecular zone. Finally, the molecules freeze back into dust grains, resulting in a balance between depletion and replenishment. Now, assuming that these slim filaments exist throughout the central molecular zone as abundantly as they do in this sample, there'd be a cyclic balance between depletion and replenishment. Silicon monoxide is currently the only molecule that exclusively traces shocks, and the silicon monoxide rotational transitions only detectable in shock regions that have both relatively high densities and high temperatures. Yang says this makes it an especially valuable tool for tracing shock-induced processes in the dense regions of the galaxy's central molecular zone. This is SpaceTime. Still to come, SpaceX's Starship to undertake a mission to Mars next year, and stranded NASA astronauts finally return home after being stuck on the International Space Station for 9 months. All that and more still to come on SpaceTime. SpaceX boss Elon Musk says his massive interplanetary transport rocket Starship should be ready to undertake its first mission to Mars next year, and if successful, humans could follow as soon as 2029. The reusable 123-metre tall stainless steel Starship is the largest and most powerful rocket ever launched. It's so far undertaken 8 test flights with varying degrees of success. While several have completed their missions, launching from SpaceX's Starbase in Boca Chica, Texas, and then landing in the Indian Ocean off the Western Australian coastline, the last 2 tests, 7 and 8, have both failed to reach orbit, ending in fiery explosions in Earth's upper atmosphere. And that's concerned NASA, which plans on using a version of Starship called the HLS in 2027 and 28 to operate as a lunar lander for the manned Artemis 3 and 4 missions, rendezvousing with the Orion capsules in lunar orbit and then transporting crews down to the moon's surface. Later on, the HLS will operate as a transfer vehicle, shuttling people and supplies between the Lunar Gateway space station, once it's operational, and the lunar surface. Musk says that next year's Mars mission will see an unmanned Starship carrying one of his Tesla Optimus humanoid robots to the Red Planet. Musk, who's also Tesla's CEO, displayed the company's Optimus robots at an event last year. He says the humanoid robots could easily be ready for sale to the public in the next few years, and the price between $20,000 and $30,000 each. He says if next year's unmanned Mars mission is successful, he believes humans could follow as soon as 2029, although 2031 is more likely. NASA's existing plans are unlikely to see humans walking on the Red Planet for at least another 10 years, using the Moon and Lunar Gateway as staging posts. Starship is key to Musk's long-term vision of colonising Mars and beyond, making the human race a 2-planet species, a sort of Plan B just in case something goes wrong here on Earth. The Starship rocket includes a huge first-stage booster called the Super Heavy, which is proving to be very reliable, successfully returning to Earth and landing back on the same launch pad it took off from. But the upper-stage Starship spacecraft has undergone continual modification, and it's still being tweaked, therefore needs more work before it starts operating reliably. Once it is, it'll replace both Musk's existing Falcon 9 and Falcon Heavy rockets, as well as the Dragon spacecraft, operating both manned and cargo flights. A space tanker version of Starship will also be needed in order to fuel the Starship HLS for its missions around the Moon. But of course the problem is space is hard, and failures are bound to continue to occur before success is finally achieved. Whatever happens, we'll keep you informed. This is SpaceTime. Still to come, stranded NASA astronauts finally return home after 9 months stuck on the International Space Station. And later in the science report, a new study warns that those of us who are night owls could be at a higher risk of depression. All that and more still to come on SpaceTime. Well, after being stranded in space for 9 months, the crew of Boeing's trouble-plagued Starliner spacecraft have finally returned to Earth aboard a SpaceX Dragon capsule. The Dragon spacecraft Freedom splashed down under brilliant blue skies off the Florida Gulf Coast near Tallahassee, greeted by a pod of curious dolphins who decided to hang around to see what's going on.
On board Crew 9 are NASA astronauts Nick Hague, Sonny Williams, Butch Wilmore, and Roscosmos cosmonaut Alexander Gorbanov, and they are now on their way to the targeted splashdown site off the coast of Tallahassee, Florida. My name is Kate Tice, Senior Quality Systems Engineering Manager here at SpaceX, and joining me today from NASA Communications is Sandra Jones.
Upon departing the International Space Station, Dragon underwent a sequence of departure burns. The crew then had a rest period and has since kicked off preparations for re-entry, including getting into their spacesuits and successfully performing a leak check. The next phase of the mission is when things will really start to amp up. Dragon has a series of steps to complete before returning Crew 9 home.
First, Dragon will maneuver to the correct attitude and jettison its trunk, which is the cylindrical, unpressurized lower part of the spacecraft. The trunk is currently connected to the aft or bottom section of Dragon, where the heat shield is located. But in order to expose that heat shield and get the vehicle ready for atmospheric re-entry, we're going to jettison that trunk.
From there, the spacecraft will use its forward thrusters to perform a deorbit burn, which will put Dragon on a trajectory to return to Earth. This burn will last about 7.5 minutes once it starts. The deorbit burn uses Draco thrusters on Dragon, primarily the 4 located on the forward bulkhead, and is executed at the apogee, or the highest point of orbit around the Earth. This deorbit burn will alter Dragon's path to ultimately line it up to re-enter Earth's atmosphere and splash down off the coast of Florida.
The heat shield itself, it is the workhorse of the re-entry phase. It will work to protect the Dragon capsule and the crew members on board during the re-entry phase as the temperatures outside of the capsule build up to, I believe, about 3,000 degrees Fahrenheit in excess of. And meanwhile, the interior of Dragon stays a very comfortable temperature. That heat shield does a lot of the work, and we'll see that plasma build up on the exterior of the capsule. As a result of the plasma that builds up, we will lose communications with the crew. This is known as loss of signal, or LOS. This is roughly a 10-minute period on average, even less than, I believe today, probably about 6 or 7 minutes long. It kind of depends on the mission.
Nominal trunk jettison.
All right. That trunk has been jettisoned from the Dragon capsule. Basically means that telemetry is looking good and that the nitrox system is primed for cabin and suit cooling, and the heat shield, like I said, is now exposed and ready for atmospheric re-entry. The trunk served its purpose by gathering energy from the sun through its solar cells and converting that to battery power. Since we separated the trunk, we can't generate any more new power, but we really don't need to since we're coming home and Dragon has enough battery power already stored. Now, up next, the final steps that Dragon will perform prior to re-entry: the slew, or the maneuver to deorbit burn attitude, and then the deorbit burn itself. This deorbit burn is the last time that the forward Dracos, which are the 4 thrusters located on top of the spacecraft under the nose cone, it's the last time that they will ignite. The deorbit burn will place Dragon on a precise trajectory to return to the splashdown zone off the coast of Florida.
And I did hear confirmation that deorbit burn is underway.
The time from undock to landing at the primary site can vary from less than 6 hours to more than 39. Getting home the quickest comes with some obvious benefits, but we always have to make sure the crew is properly rested for dynamic operations.
Deorbit burn complete. Performance nominal. Nose cone closure initiated.
We heard the words we were looking for, nominal burn. So that means that deorbit burn was successful, and nominal meaning as expected. And we're now beginning to close the nose cone in preparation for atmospheric reentry.
Also, the vehicle has initiated the nitrox suit purge, which will help keep Nick, Sunny, Butch, and Alexander cool and comfortable during reentry.
Things are going to start moving quite quickly. In fact, if anything, this will have seemed like the slower part of the reentry phase. We're going to go through, like I said, that period of loss of signal, or LOS. We'll go through that period approximately at about 18,000 feet when the capsule is traveling at 350 miles per hour. We will see our first views of parachutes for the day. We'll see the drogues come out. Those drogues will help slow the vehicle down to about 119 miles per hour. And then that is when the main parachutes will come out from the Dragon spacecraft and then ultimately end in splashdown.
Freedom, SpaceX. Nose cone is secure for entry.
Freedom copies.
Freedom, SpaceX. For entry sequence. Report when ready to copy.
Ready to copy.
All right, I've got some updated times for you. Our COM blackout start time is 2144. Our COM blackout end time is 2151. And our splashdown time is the same per your displays, 2157.
Okay. Understand, COM blackout start 2144, stop 2151, splashdown per display.
That's a good readback.
And copy, welcome.
The capsule is making its way through the Earth's atmosphere, using the atmosphere to slow the capsule down from its orbital speeds of 17,500 miles per hour.
Our tablets are secure, restraints are tightened, visors down. We are configured for entry.
Freedom, I copied. Tablets are secured, restraints are tight, and visors down. Predicted COM blackout. We'll see you on the other side at 2151.
2151. Talk to you soon.
We, right there, have our first view of Dragon Freedom coming home to Earth.
And that view is from the WB-57, which is one of NASA's high-altitude planes that is tracking, beginning to see that plasma trail as Dragon re-enters the Earth's atmosphere.
Freedom, SpaceX, comm check.
SpaceX Freedom is with you. 4.6G. Enjoying the ride.
Copy that, Freedom.
Great news there from Commander Nick Hague reporting back.
We see a healthy flight computer. Expect automated chute deployment.
Freedom copies.
Dragon Freedom makes its way home.
GPS has converged. Expect nominal altitude for drogue chute deployment.
Now the heat shield is continuing to work to slow the vehicle down. That entry period, the Dragon spacecraft went from orbital velocity about 17,500 miles per hour down to about 350 miles per hour. So it really gives you a sense of why that plasma builds up on the exterior of the capsule, thanks to the heat shield and the work that it does. Those drogue parachutes will slow it down from 350 to about 119 miles per hour. We can see
15 kilometers. Brace for drogue window.
Drogue deployment.
Drogue descent rate nominal.
the crowd here.
Visual on 2 healthy drogues.
The crowd here very excited as Dragon Freedom continues to make its way back to planet Earth.
Next up, we'll stand by for the main deployment of the parachutes. Freedom will be traveling 16 miles per hour when it splashes down.
We have visual on 4 healthy mains.
Freedom copy.
We'll start to hear Commander Nick Hague.
Copy 1000.
As we heard right there, Commander Nick Hague will be calling out the altitude of the Dragon capsule from here on out. Those parachutes continuing to slow the Dragon capsule down.
800 meters.
We do have 4 healthy mains really doing the job there. Calm, glass-like ocean off the coast of Tallahassee, Florida. Crew 9 just minutes away from splashing down.
That
Copy
was
600.
our recovery vessel, Megan, which is stationed a couple miles away from the splashdown site.
400 meters.
This is a gorgeous bluebird day here that we have for the splashdown of Crew 9.
200.
Copy 200 meters. Brace for splashdown.
Stand by for splashdown located in the Gulf of America off the coast of Tallahassee, Florida.
And splashdown. Crew 9 back on Earth.
The splashdown marked the end of a drama which began back on June the 5th last year when Starliner launched on its first manned test flight aboard an Atlas V rocket from the Cape Canaveral Space Force base in Florida. It followed 2 earlier unmanned Starliner test flights. The first in December 2019 was plagued by computer programming issues. That saw Starliner's mission clock set 11 hours early, causing the spacecraft to enter orbit too early at too low an altitude, therefore meaning it was unable to reach its intended target, the International Space Station. To make matters worse, just prior to its deorbit and return to Earth, mission managers discovered additional computer issues aboard the Starliner. And these were far more serious. In fact, they would have caused the capsule and its service module to collide during their planned separation prior to atmospheric re-entry. And that would have been catastrophic, destroying both vehicles. Later, it was also discovered there were other problems which would have prevented Starliner from docking with the space station anyway. Once back on the ground, a complete re-evaluation of the Starliner spacecraft and its systems were undertaken by a joint investigation team headed by Boeing and NASA. That resulted in more than 155 changes being ordered. A second test flight, slated for November 2020, was cancelled due to more software issues and the discovery of corrosion damage to 13 propulsion system valves, resulting in the need to undertake a complete rebuild of the spacecraft with a new service module. See, the valves had been corroded by the intrusion of moisture, which interacted with the propellant, but the source of the moisture was not apparent. A second orbital test flight finally launched in May 2022. But it too had its problems. 2 orbital maneuvering and attitude control system thrusters failed during the orbital insertion burn. Nevertheless, the spacecraft was able to compensate using the remaining thrusters, as well as the addition of the reaction control system thrusters. And a couple of RCS thrusters used for maneuvering Starliner also failed due to low chamber pressure during the docking phase to the International Space Station. Some thermal systems used to cool the spacecraft also showed extra cold temperatures, requiring engineers to manage it during the docking. The spacecraft eventually returned safely to Earth, landing at the White Sands Missile Range in New Mexico 6 days after its launch without incident. But once back on the ground, other problems were detected. These included issues with the harness straps on the parachute system. They required additional strengthening. But then a more serious problem was detected when it was realised that the glue used on the insulation of the spacecraft's electrical wiring system was flammable. Those issues pushed a potential manned test flight launch back to June 2024. But what was meant to be an 8-day test flight for Starliner crew members Sonny Williams and Butch Wilmore turned into a 9-month stay. As Starliner arrived at the International Space Station, 5 of its 8 reaction control system thrusters malfunctioned. There were also persistent helium leaks, which weren't a problem as the inert gas is only used to keep the fuel systems pressurised and there was still plenty in reserve, but it was evidence of underlying issues. Mission managers eventually got 4 of the 5 problematic thrusters operational before clearing Starliner to approach and dock with the orbiting outpost on its second attempt. Once on board the space station, Wilmore and Williams joined the Expedition 71 crew's 7-member team for what should have been a week-long stay. However, after extensive troubleshooting and the discovery of additional issues, NASA, despite protests by Boeing, decided Starliner was simply too unreliable to undertake the return journey with a human crew on board. The orbital manoeuvring propulsion systems simply weren't safe enough for human spaceflight. And so Starliner returned to Earth unmanned on September the 7th, landing safely as planned at White Sands. NASA decided the Starliner crew would instead remain on station and return as part of SpaceX's Crew 9 mission, which launched aboard their Dragon capsule Freedom on September the 28th for a 6-month stay. The change in plan meant the original Crew 9 was reduced from 4 to just 2 for the flight to orbit. The mission proceeded nominally, with Wilmore and Williams acting as replacement crew members taking part in normal space station research and activities. And they remained on station until the arrival last week of NASA's next crew rotation, SpaceX Crew 10. That arrival paved the way for Crew 9, including Wilmore and Williams, to finally return to Earth. This is SpaceTime. And time now to take a brief look at some of the other stories making news in science this week with a science report. The World Meteorological Organization has released its State of the Global Climate Report for 2024. The report confirms that last year was indeed the first calendar year to be more than 1.5 degrees Celsius above pre-industrial levels, making it the warmest year in the 175-year observational records. The report also shows that the atmospheric concentrations of carbon dioxide are now at their highest levels for at least 800,000 years. And each of the past 8 years has set new records for ocean heat content, and the rate of sea level rise has doubled since satellite measurements began. The World Meteorological Organization says China remains the world's biggest carbon dioxide polluter, producing over a third of the world's total greenhouse gas output. That amounts to more than 14 million tonnes annually. That's more than double that of the United States, which is in second place, and 5 times more than India, which is in third place. A new study warns that night owls could be at a higher risk of depression. The findings, reported in the journal PLOS ONE, looked at data from a survey of 546 university students, which examined sleep patterns, mindfulness, tendency to overthink and dwell on things, alcohol use, and depression and anxiety levels. On average, night owls had poorer sleep quality, higher alcohol consumption, and they acted with less mindfulness than early birds. While this kind of study can't show cause and effect, the authors say targeting mindfulness, sleep, and alcohol use could reduce depression risk in night owls, especially young people. Scientists have discovered the fossilised remains of a new species of fish that lived in Australian freshwater lakes and rivers 15 million years ago. A report in the journal Vertebrate Paleontology says several examples of the ancient fish, Ferroapsis broxi, were uncovered at the McGrath's Flat fossil site near Gulgong in the central west of New South Wales. The fossil is part of a diverse group of fish species within Australia that includes fish like the Australian grayling and the Australian smelt. The discovery offers scientists an unprecedented opportunity to understand Australia's ancient ecosystems and the evolution of its fish species. The authors found the stomach contents of the fossilised fish were so well preserved they could tell its last meal included a range of invertebrates, such as small phantom midge larvae. In fact, they could also tell the shading of the fish, which was darker on its dorsal surface, lighter in colour on its belly, and had 2 lateral stripes running along its side. A bit of bad news now, and it seems the pseudoscientific practice of physiognomy is making an unwelcome comeback thanks to artificial intelligence. Physiognomy is the junk science idea that you can work out a person's true character simply by studying their face. It was proven to lack any scientific legitimacy centuries ago, but it's now seeing a revival thanks to AI programs which claim it can identify latent traits in people that human judgment can miss. Tim Mendham from Australian Skeptics says, like all computer programming, it's only as good as the data fed into it. So another case of garbage in, garbage out.
You wonder at times if the artificial intelligence follows the 3 rules of robotics. But,
it doesn't, unfortunately.
It doesn't. No. Okay, this thing about technology being used for a pseudoscience is the science, in quotes, very much in quotes, of physiognomy, which is basically reading someone's face. Phrenology, you probably know, is reading the bumps on someone's head to know what sort of person they are, their character, etc. But this is reading someone's face, and you can actually use that to decide very, very detailed assessments of not just their character, but the sort of activities they do, criminality, sexual orientation, political leanings, all these sort of things. It's a pseudoscience. Most of us will see someone, they look angry, you think they're an angry person. Or they look happy, that's a pretty happy person. And you don't go much deeper than that. You certainly don't go into, I can look at you and I can say you're a brain surgeon just by looking at your face. So it is a pseudoscience. It's been around a long time. People have tried it occasionally. Now, thanks to AI, they're using it to basically look at a lot of faces and to find common traits. So far, so good. But the trouble is, what those traits indicate have been put into the system, obviously by people. And they decided that that particular trait indicates that outcome. So what it means is that as the stories went, that especially European faces were always regarded as superior faces or indicating superior intelligence than other races. And it becomes a racist methodology because it's the input of data is saying this face is a good face, this face is a conniving face. You could say if someone has a monobrow, single brow, does that mean they tend to vote for a Green Party? No. If someone has a crooked nose, does that mean they're going to end up being criminal? No. If someone's eyes are a certain distance apart, does that mean they're going to be have a certain sexuality? No. And that's what this relies on, stereotyping, based on total pseudoscience. So even if the technique of saying this face is similar to that face is similar to that face has the characteristics, and no two faces are exactly the same anyway, the input, the data, what that means is false. And it's what that means is often biased. And therefore you're using a new technology based on very inaccurate data inputs. Underpinnings are wrong. So you can use any technology you like, but if your basis is wrong, the answer is wrong. And that's what you're finding with this thing. It's a pseudoscience. The trouble is, it's then used by a lot of people in assessments. It's now being used by recruitment people and could be used by a whole range of different people to judge someone.
That's Tim Mendham from Australian Skeptics. That's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.